Math demystified. Circle geometry.
Theorem 1. A straight line drawn from the center of a circle to bisect a chord, which is not a diameter, is at right angles to the chord.
What the theorem is saying is that when you have a chord, say we have chord AB, and from the center of the circle, a line is drawn and the line makes angle 90 degrees with the chord, this line has successfully bisected the chord AB. That means it has divided chord AB into two equal parts. Sometimes you'll be given a question like this, and if you look at the question properly, you will discover that there are two right-angled triangles. So for you to be able to find either the side or the angle, you will either need trig ratios or Pythagoras theorem.
Theorem 2. The angle that an arc of a circle subtends at the center is twice that which it subtends at any point on the remaining part of the circumference.
What the theorem is saying is that from this arc given, if I form an angle at the center, and from the arc again, I form an angle at the circumference of the circle, the angle formed at the center is 2 times the angle formed at the circumference. So if I call this M, this will be 2M. Now, this diagram can be drawn in different ways. So imagine that these lines are such that you can move them like the hand of the clock. So if I move this and I move this one this way, it will form something like this. So if I move them from where they are, they will come this way. So if I do that, this will be the angle formed at the center, and this will be the angle formed at the circumference of the circle. If I do the same thing here, I move it from where it was, it got to this place, it goes past it to this place. This will be the angle at the center, and this will be the angle at the circumference. This diagram can actually be drawn in different ways. Now, let's be creative with the diagram. Let's assume this is the arc. This is the angle formed at the center. Don't forget I said from this place, if I can draw a line to the circumference, and from here, I draw another line to the circumference, the angle here will be twice the angle here. So I want to be creative with it. So from here, I trace to the center and go back. I still continue with this line to the circumference so that this one forms a diameter now, and this one meets it. So this is the angle at the circumference, this is the angle at the center. An angle at the center is twice the angle at the circumference. Let's also look at it in another way. This is the arc, this is the angle at the center. Go back, and I move this one again to the circumference. This is the angle at the circumference. So the angle at the center is twice the angle at the circumference. Now let's look at this diagram. This is my arc. This is the angle at the center, which I have called P. My arc, angle at the center, I've called this P. And from this place, I trace to the circumference. From here also, I trace to the circumference. So, and I've called this angle at the circumference, I called it 40. What will P be? P will be 80. And what do you think Q will be? Q should be half of this. Q is 40.
Theorem 3. Angles in the same segment of a circle are equal.
The theorem states that angles in the same segment are equal. This is a chord AB. That shows that this lower part is a segment. This upper part too is another segment. From these ends, if I trace to this circumference here, and I trace to this circumference here, in the same segment, these angles are equal. From here too, if I trace and I trace like this, these angles are equal to themselves. That is what the theorem says. Now look at this diagram and bring out all the angles that are equal to this using the same theorem, same segment. So let's do it together. This is my A. I'll trace the A down and trace it up to the same segment. So the A is equal to D. So this is D. Okay, letter H. H is here. I trace it here. And I trace it down here. That is E. H is equal to E. And I have B. This is my B. I'll trace it to its source. Then back to the same segment. So B is equal to G. Then let's look at C. C. I'll trace it to its source. Back to the same segment. That will be F. You can pause the video and go over it.
Theorem 4. The angle in a semicircle is a right angle.
What the theorem is saying is that when you have a semicircle and from these ends you create an angle at the circumference, the angle created will be 90 degrees. See, you can also go this way, it will be 90 degrees. I could even come like this, it will be 90 degrees. If I go like this, you know this one too is a semicircle. If I decide to come like this, it will be 90 degrees. That is what the theorem is saying. And it is true because if I look at this angle here, angle at the center is 180. So if I trace it, angle at the circumference too should be 90 degrees.
Theorem 5. The opposite angles of a cyclic quadrilateral are supplementary, or angles in opposite segments are supplementary.
This theorem states that when you have a cyclic quadrilateral, meaning you have a quadrilateral inside a circle, not around the circle, but inside the circle, such that all the vertices of the quadrilateral are touching the circumference of the circle. If any of the vertices is not touching the circumference of the circle, it is no longer a cyclic quadrilateral, and this law will not hold. So the theorem states that these opposite angles, when you sum them together, they will give you 180. So x plus y equals 180 and a plus b equals 180.
Theorem 6. The exterior angle of a cyclic quadrilateral is equal to the interior opposite angle.
This diagram is the same thing as this previous diagram. The only difference is that one of the lines is produced, meaning that one of the lines is extended. So the angle that will be formed here is called exterior angle. It will be equal to this interior opposite angle. How do you easily know the angle to be equal to? Look at the angle you are given. Say you look at the exterior angle here. Then look at the angle that is adjacent to it that will make it become 180. The one in front of the angle is the one that is equal to the exterior angle, and this is called interior opposite angle. Let me draw another exterior angle and you locate the interior opposite angle. Where is the interior opposite angle? So if you look at this, this is the adjacent one that will make it 180 degrees. This is the one in front of it. So here becomes B. Let me draw another. If I call this angle C, which angle is C? This is the exterior angle. This is the one that makes it 180 when I add it to it. This is the one in front of it. This is my C.
Theorem 7. A tangent to a circle is perpendicular to the radius drawn to its point of contact.
This obviously is one of the simplest theorems, and it is very easy to recognize. How do you recognize it? When you have a tangent and you have radius, where they both meet, there is 90 degrees. You have tangent, you have radius, there is 90 degrees. That's all. Sometimes you could be given a diagram like this. This is radius, this is your tangent. Definitely you have 90 degrees here. So 90 plus 72 plus B, 90 plus 72 plus B will give you 180 degrees. And from there, you can get your B. And that's all.
Theorem 8. The tangents to a circle from an external point are equal.
The meaning of the theorem is that when you have a point outside the circle, not inside, outside the circle, and you draw tangents, two tangents. So from this point to where it touches the circle and to where it touches the circle. So it touches circle at A and B. So the theorem is saying that AP is equal to BP, and that's it. Now let's look at this diagram. This is my circle. This is a point outside the circle. This is another point outside the circle. Here is another point outside the circle. This line is tangent to the circle at this point, X. This one too is tangent at Y, forms a tangent at Z. So if you follow the theorem, you will discover that this, from this place to this place, this distance will be equal to AY. And BX, this line, will be equal to BZ. Please follow carefully. Then CY will be equal to CZ. Now, let's bring back some of the theorems we have learned. This is a tangent. This is radius because this is the center of the circle. So this place is 90 degrees. Here too is 90 degrees. This is 90 degrees, under 90 degrees. This is 90 degrees, is under 90 degrees. Let's be creative with this diagram. Let's come over here and draw a line. Let me do the same thing here. And let me do the same thing here. You will discover that these are radii. That means they are equal to themselves. That obviously means that I have an isosceles triangle here. I have another set of isosceles triangle here. And I have another set of isosceles triangle here. Same thing is applicable here. I have another set of isosceles triangle here. Another set here. And I have another set here.
Theorem 9. If a straight line touches the circle, and from the point of contact a chord is drawn, the angles which the chord makes with the tangent are equal to the angles in the alternate segments.
How do we recognize this theorem? There's going to be a triangle inside the circle, and the vertices of the triangle will touch the circumference of the circle. Then you have a tangent. So this is definitely a chord, and you have a tangent here. This angle that is formed here, look at the chord. The angle facing the chord is the one that is equal to it. I'll repeat that. I have a tangent, I have a chord. The angle facing this chord is this angle. That is the one equal to this, and it is alternate segments. There are angles in alternate segments. Now, let me draw another line. If I pick this angle, which angle will be equal to it? This is the tangent. This is the angle it makes with the chord. Let's call this B. That means that this is the chord. This is the angle in front of the chord. This place is my B. If I decide to draw a tangent here, and I pick this angle, and I call it C, which angle will be equal to it? This is the tangent, this is the chord, this is the angle in front of the chord, this is my C. Let's keep playing. If I pick this angle, which angle will be equal to it? This is the tangent, this is the chord, it will be equal to this. So this is also A. If I pick this angle, which angle is equal to it? This is the tangent, this is the chord, so this is C. And if I pick this angle, which one will be equal to it? It will be B. Thank you for watching. Click like if you enjoyed our video. Please do not forget to subscribe to our channel so that you can get notifications of our subsequent videos.